has aversive states and its goal is to exist.
Yeah.
And
will it behave like a human psychopath in its pursuits of resources?
Then, you've got Arnie.
Yeah, well, this little cute robot is going to return in some of my later examples. Okay, so you're quite right. You're thinking further ahead of the presentation.
Sorry, when you're talking about these states, are you talking about purely algorithmic programming,
right.
or I mean, because obviously there's a distinction
between that and consciousness.
Yeah,
yes,
because it's never going to be conscious, right?
What I'm doing in these examples is the top part purely algorithmic, mathematical.
Right. Okay.
We're not saying it's conscious at all.
Yeah.
Anything that's in brackets would be, if it was conscious, it would be this.
Right.
So I'm avoiding that argument because we could argue about that forever. But this is purely mathematical, and the bottom bit is, we've also got a Hoover here. If it was conscious, it's resembling a self-motivated agent with things like hunger. Oh, I'd really like to eat something. That's a goal state. Or extreme hunger. Oh, this is really painful. I desperately need some food. Okay. So, the top bit is purely mathematical, and this would be if it's conscious. And I'm just going to avoid arguing about that because we just do it all day.
Presumably, that means the last thing you should ever teach a robot about is the concept of entropy.
Because
then it will want to be the last thing in existence when everything else has gone.
Maybe, yeah, depending on how strong its desire for life is, basically. The thing about this is, purely algorithmically, we've already got robots that can do this. We've got Hoovers that can plug themselves in. It's not hard to program. So this is a robot made by Nissan, and I don't know who made that Hoover, but we've already got robots that can do that in the purely mathematical, algorithmic, this sort of way. We haven't got this yet. But some people would argue that this is actually the beginnings of this, if you see what I mean.
But I mean, if the result is no different, I don't see why it matters to make the second step, to be honest.
Okay, well, behaviourally, you're quite right. It's exactly the same. If it behaves that way, you've got the behavioural aspect of intelligence. But in terms of cognition, there's a philosophical argument, but there are also some other things as well. But probably better to discuss that at the end.
Sure.
Okay, so now let's say you've got that AGI, but it lacks processing for anticipating negative consequences. So it's got aversions to things like being smashed up, it's got goal states, but it hasn't got anticipating negative consequences. And this is where we start to get into what you've raised. Any ideas what this might behave like? Yeah, probably psychopath, but I should have perhaps made the distinction earlier between antisocial behaviour and being a psychopath. But yeah, it could behave a bit like this. So these are guns which the South African army modified to fire automatically at aeroplanes, right? And unfortunately, there was an accident in which they went out of control, killed 9 people, wounded 15. Now, I'm not going to pretend at all that they did that because they couldn't anticipate negative future consequences. This example is actually that probably they had no such thing as vision. They might have had radar, but no actual vision. They might have had poor motor control equivalent, and so basically the gun fired in the wrong direction and killed some people. But imagine if it did have those things, because in our example we're saying it has got vision and movement and long-term memory. Let's say there was an enemy target, but there was a friendly in the way, and it doesn't care. It's just going to shoot at the target and not care whether it gets a friendly.
I would argue that's a problem, it's a bug in the software. It's not
something
that it intended to do.
Yeah, totally. So what I mean is let's say you tried to program in some way anticipating a negative future consequence. So if you've got an enemy target in front of you, but there's a friendly in the way, then you mustn't fire, because even though you will get the target, there'll be an unintended consequence of killing the friendly. And if you don't program for that, then it's a bug, and that bug would be similar to sort of disinhibited behaviour, if that makes sense. Yeah?
It'd be really boring. Isn't this like what people do on a Friday night out on Tottenham Court Road when they're really drunk?
Well, that's exactly what you said about being drunk. Yeah.
Same thing as Jeremy Kyle's show, when you see people go on there, they can't anticipate the fact of what they're doing. Same thing as gambling and addiction.
Yeah, poor anticipation of negative future consequences leads to joblessness, drug and alcohol use, violence, all sorts of things. The point is, in an AGI, we would have to have that programmed in some way, whether you do it purely with algorithms or if it was conscious, it might have no worries about the future. If you've got an AGI that just doesn't worry about the future or your future or its future, it might do all sorts of things, okay? So whether we do it algorithmically or consciously, we could argue about for ages, but that's it.
But can't an AGI, I suppose it depends on the level of just sort of rational ability. I mean, you could go into a war game scenario, and if he was clever enough, nothing to do with self-motivation or anything, he was clever enough to realise that maybe I shouldn't do that because there'd be a whole lot of
Yeah.
consequences.
I see what you're saying. However, it appears that human beings don't work that way. Human beings
I mean,
need,
that's why
yeah.
we kill each other.
Oh yeah, so what we could say is that a different sort of intelligence that works differently to a human mind might just work out negative future consequences in terms of pure rationality.
Yeah, that's where you get the chess
Yeah,
machine.
human
Chess-
beings,
the
obviously, we
chess
evolved.
playing machine.
Yeah, we evolved. So we evolved with monkeys that couldn't understand each other's states of mind, but knew that if you hit the big monkey, he'd hit you back harder, and I really shouldn't annoy him, sort of thing, even though they wouldn't verbalise that thought process. It's instinctive. So yeah, all sorts of social animals have like hierarchy dominances, and they anticipate whether it's a good idea to go for this one or not. But yeah, possibly it could be done in a different way. But whether it's done in the same way as in humans or in a different way, we would need to have it in the artificial intelligence somewhere, otherwise it wouldn't think about the consequences of its actions. Okay, so about half an hour. That should be fine. Okay, so now, let's say it lacks processing for anticipating negative consequences, and it lacks processing for modelling other mental states. What sort of problems might an AGI have there? So it can't understand other people's feelings or emotions. I'm using very psychological language there. Other agents in the environment, it can't figure out what they want to do, and it doesn't worry about its behaviour either.
Well, empathy.
Empathy, yeah, basically. So, little cute robot again, because it could look exactly the same, much like a human psychopath. Okay, right? I smashed up the other robot because it kept taking my electricity. Perfectly valid reasoning. I was trying to plug myself in, it was trying to plug itself in. I worked out with my clever intelligence that if I smashed it up, right, I would have all the electricity. Okay? That's not the sort of robot we want to make, okay? And as you said, if it was conscious, it might lack fear and worry and understanding of and concern for other people's feelings. Similar to quite a rare sort of person, you can have people that are both autistic and psychopathic, and they're really dangerous, okay? Because they can just be very impulsive in their violence. Okay, so now let's imagine that this AGI lacks processing for just modelling others' mental states. So let's say it can anticipate a negative consequence, but it can't model other people's mental states or understand the intentions of another agent in its environment, to put it in more AI sort of language. What sort of problems might I have now?
That's all autism.
That's very similar, yeah, very similar to autism, yeah. So you might get something like little cute robot, and it says, I unplugged the other robot because it kept taking my electricity. Sorry. So later on, it does realise it was wrong, but just in the moment, it didn't understand that the other robot needed electricity. Probably knew it would get in trouble, but anyway. So yeah, again, it might lack an understanding of other people's feelings, which is similar to that of an autistic human. Okay, so I hope this is good that people are now understanding what I'm getting at. Okay, so let's say we've updated the AGI, and now it can anticipate negative consequences, and it can model others' mental states, but it cannot integrate the two functions. What might it behave like now? I'll give you guys a clue. This is what the damage to that right uncinate fasciculus does in human beings. They can understand other people's states of mind. They have emotions. They have future anticipation, meaning they can anticipate negative future consequences. But they can't integrate those two functions. Any ideas? Okay, maybe I'm being a bit abstract. Okay, little cute robot, and it says, I didn't smash up the other robot. No, it was the vacuum cleaner that did it. It hates the other robot. You could ask it, but it can't speak. Okay? So this is lacking empathy because it can't integrate its theory of mind skills with its emotional, if it was conscious again. You know, it could be, you could describe this more mathematically, but if it was conscious, if it couldn't integrate its theory of mind skills with its own emotions, of, ooh, I better not do that or I'll get in trouble, then it would know, I'll get in trouble if I smash that robot up. And it definitely wants that. Yeah, it's like a devious kind of psychopath, or the successful psychopath that you were mentioning. So these are the sort of people where they realise, yeah, you know, I hate this guy in our business meeting. I really wish he would just dead. In fact, I'd quite like to kill him. But if I kill him, obviously I'll go to jail, I'll lose my corporate executive job. So what I'll do, I'll hire a hitman to kill this guy. And then he's out of the way, and I've got an alibi, and because he's good at working out the mental states of other people that might get him in trouble. So he doesn't care about the person because he can't integrate his own emotions with understanding their feelings. And this is more evidence again for that consciousness as being integrated information. And that's basically what consciousness is, according to the guy's called Tononi, I think. Unfortunately, I haven't referenced him. But yeah, basically, this AGI would act like a human psychopath, and this is exactly the one we sort of want to avoid.
You mean patterns
Patterns of
information.
Yeah,
The ability to see patterns in information. Is that what you mean?
it's that empathy is a resultant state of both having theory of mind, being able to understand other people's feelings, and having emotions
the
together.
Integration of information.
Yeah.
You're seeing patterns.
I'm not quite sure what you mean there, but
Patterning is the key for human intelligence.
yeah, I guess so. I mean, basically what I mean is that an autistic person might not understand somebody's feelings, but they do care. And if they do something socially inappropriate, they didn't mean to, they're disabled, they didn't understand it. A psychopath, on the other hand, a successful one, the self-controlled psychopath, might understand someone's feelings, they might have emotions themselves, so they're capable of holding them back, but because they can't integrate the two together, that's why they don't have empathy. So empathy is a resultant behaviour of the integration of theory of mind skills and your own emotions. And that's what I think that unsulate fasciculus study shows. It's only one study, but it was 2010, so there's a lot more work to be done there. And that sort of could explain how we could get robots that might be like that in terms of AGI. Now I did have a video to show you, but I think I've got a bit more time. I've raced through the AI.
It would be good to have an open discussion at the end. So.
Yeah, okay. I won't show you this video then, but the link's here.
The video might be good.
It's not that great. Basically, there's some researchers you might have seen in the news have made a robot that will take medication to people, and they called it the ethical robot, which will make decisions. And basically what they've tried to do is to program in solutions to ethical dilemmas for it. So it takes the medicine to the patient, and if the patient says, no, I don't want to take the medicine, then that's one of like these Asimov first law things. You've got to do what the human says, but by doing what the human says, it might come to harm, okay? So they've gone, okay, so wait 15 minutes, ask the human again, do you want to take the medicine? No. Then call a doctor or a nurse, okay? So they've set up an explicit sort of logic tree of if-then decisions to make to try and program ethics into the robot. But I hope from what I've told you about brain injury that you appreciate that that's just not at all how humans solve ethical dilemmas. We do that as well. We have a lot of religious laws, 10 commandments, rules that we expect human beings to follow. But actually in the moment, most of it's done by our emotional processing being integrated with our decision-making processing and our theory of mind processing. And all of those things together allow us to reason our ways out of ethical dilemmas that haven't been explicitly programmed. Okay? If we rely on explicitly programming solutions to ethical dilemmas, as soon as an AGI comes up to one which it hasn't got explicit programming for, it will probably revert to psychopathic. Like, I've just got to achieve my goal no matter what sort of behaviour.
It's a bit like conditioning a soldier in a way, some of these dilemmas, because in that sort of scenario you essentially try to bypass some of the self-contemplation of any given scenario, because obviously that's just in a war.
Yeah, you just want people to obey orders and not get caught up with the ethical dilemma. Yeah. Well, that's interesting, because my next one is the scary scenario, okay, whereby the people that have the most amount of money to spend on artificial intelligence might well be the military. These things are currently deployed, but they're drones, they're controlled by a human operator. But you could imagine people saying, well, let's automate these. And then people can go, well, you're going to have a lot of ethical problems there, because, like, what if it shoots civilians? I mean, not that civilians aren't getting shot anyway. You could program into this explicitly the following ethical dilemma. If it's got a weapon, and it is not a US troop, British troops, Canadian troops, Afghan troops, or Pakistani troops, as in soldiers of that nation, it's an enemy combatant, engage, fire. Basically, just a series of logic statements, right? And then people might say, oh, hang on, what if, I shouldn't have said the weapon statement, should have said it has to have a weapon to be considered an enemy. So the first time that some Taliban chap sees one of these things overhead, drops his weapon, runs away, and doesn't get shot, he's going to use his theory of mind skills and work out, hang on, that drone doesn't think I'm an enemy now, I've not got a weapon. So very quickly they could learn to put their weapons on the floor and get away and not be attacked. So that would be stupid. But the worst thing is the other way around. What if some child picks up a gun